You can notice here that the BA, which is bus available, which is connected to the CPU, it is sort of on for 3 cycles before it actually takes over. And the reason for that is, as it said in this document, that when the CPU is doing something, it takes 3 cycles to finish at the most. So, and another thing you can see, so when you come over here, you have only 1/2 cycle or something before it gives up, or it gives it up all at the same time as VA goes up. But here is a delay of 3 cycles, and you can see this repeats. If you have a sprite, for example, and here we have sprite 0, and the next sprite 5 to 7. So you can see if you get sprite 5, it has to, the BA has to go low for 3 cycles before. So this is what we're going to look at in this video. So this is the BA line, so I've traced it, and it goes up here somewhere. We have a lot of things we're going to look at this time. I'm at work, so just turn on some stuff here so you can see better. Y counter, and this is X counter. So before I go, I just show you. There you go. So this is the X counter. So that's for every pixel on the raster. This counter will increment, and then when it reaches a certain point, I think it says down there, is a bit difficult to read actually. Yeah, 170 and 148 in hex. Or this is the way I read the hex numbers anyway. So please don't comment. Goes into latch. And down this latch goes up here and over here. So this is the same as sprite bus available for sprite 0. So, and I posted a image on Twitter. I was wondering, why do I see this here? What is this thing here? So it all started here. And I saw this pattern, zigzag pattern here. So what you have here is a dynamic latch. So every time it passes here, it's delayed half a cycle. So because these 2 clocks, they are half a cycle apart. They have the same frequency, but they are sort of shifted apart. So we will simulate this. You can see it. So the sprite buffer comes in here, delayed by half. Full, 1.5, 2, 2.5, 3. So it's delayed by 3. That's what I mean by 3. And then, sorry, and then it comes up here, and something happens here. I'm not sure what's going on there, but eventually you will get. Yeah, here you go. Here it will fire a BA. Thus available. And this is a domino effect. So when that has happened, it will travel to the next one, and to the next one, and to the next one. So you have 8 sprites. Whenever they are enabled, it will fire BA. So let's follow that. Down here, I think. So yeah, so that line goes directly down to this part. So you can tell that it's generating this signal. But how about the AEC, which is used directly with the address bus? You can see that this waveform has something to do with AEC, so we will look at that. Yes, I will look at that when I get home. So I thought I will use the camera now because I want to simulate the circuit. Actually, I was going to use this one. I made like a shift register, dynamic one, but it doesn't work with transistors because transistors have, and most transistors, they have body diode, so it works one way but not the other way. So, or the signal. So yeah, so first we're just gonna look at this part, which we saw in the beginning of the video. You see that SPBA comes in here. It goes through past transistors, inverted, pull up there, another past transistor, and so on. So that's what I've done here. Now you may recognize this history. By the way, this is Digital Works. And now, the first time I made this video, I used Digital Works, but it wasn't free. So I just had I don't know, it was like trial something. But now it's license free, so now you can download it. And look, I found out you can do history. So if you put text and add like text, this is a really old style program, but you can add it to logic history and they will show up here. And in the beginning of the video, you may recognize this signal. Look. So you have on top here you have the signal. You see 3 cycles out, and here it starts cycling at once. When BA goes up, same thing here. BA goes down, 3 cycles. However, you see it's inverted though compared to this one. But anyway, and on this other side, you see when BA goes up, the output starts cycling right away. The AEC, actually, as you can see, it's the same thing in the simulation. So how did I simulate this? Well, you can put numbers here and follow and such, but it sort of just took 1 and 1 transistor and made it into a logic or register transfer label, if you can say it like that. So these are pass gates. So you have 5 0 and 5 1. You can see when I run it, you can see they just alternate. And then every other pass gate has every other. They are even odd on the. So you can isolate the signal to shift from left to right. So if I hit this one now, I have to click this first. And this one, you can see it starts shifting through here, and eventually it will go out. Okay, it's already out actually. Hold on, click it again. There, it's over there. So let's look at this part first, and then we can look at this down here afterwards. So basically this circuit goes over here into this buffer, which drives BA, and BA is bus available. So we have bus available up there. Goes down to like the the output pin, the driver for it, comes in here, the signal all the way from that transistor we saw, comes up here into some decoder, so or demultiplexer. So it drives pull and push here, but also it continues. So it sort of uses this one as a transistor or amplifier for sending the signal away again. So it's weird that it does have to go all the way down here and then back out again. but let's see where it goes. So it goes up very close to the AEC pin, and this looks very much like the same pattern we saw, zigzagging down here. And here comes BA there, up here, the metal, and then through the pass gate. So that's what I've done here. It's a bit different because, let's zoom in, you can see better. You see it comes in here, and then it inverts, but it's not actually an inverter in that sense, because you also have a transistor here, so you get a wired OR, but it's not an OR, it's a NOR, because it goes to ground. So these two are the inputs to a NOR gate. That's what I have in the beginning, preceding a pass gate. So, and this follows in this panel. You can see it here. I could show you, but it takes so much time. So basically we can try and see what happens. So when this one goes low, this one will go low there, and it starts blinking. This is hard to follow, so it's better to look at the history. So now it's running. Let's turn it high. There it goes high. It starts pulsing right away. Let's take bus available low. There it goes low, pulses 3 times, and then stops. Then the CPU, or then the VIC has the CPU. So now there's one thing I haven't told you, and this is something that's used in FPGAs also, synchronization flip-flops. So when I tried to do this first time, I had a button over here, and that doesn't work so well for simulation, because then when I press the button, you never know if it's in the middle of first or second half of the cycle. So then you have something called synchronization flip-flops. Just basically means you have 2 flip-flops in series. Yeah, so what I was going to show you was the asynchronous. So add it to logic, so we get it up here. And then when I start it, it starts going, and let me click it. You can see it goes up there. Then it starts, goes down. You see, I clicked in the middle of a cycle. However, the output, which is a bit, which is a bit later in the shift register, it comes right on the edge. So here it's asynchronous, and here it's synchronous. So yeah, so I can also add these 2 guys. Add the logic. So try that again, just for fun. Click it asynchronously. Click it asynchronously, and then boom. So thank you very much for watching. This wasn't the big video, but it was a lot of work to get here. So and I figured out a lot of things. So hope you liked it. See you another time. We'll continue work on this. Bye bye. By the way, I'm finished with all the dots, or the vias. So the vias, I can show you the bitmap, because it takes a bit of a while. So basically just dots. You can see it's crazy how many. So this isn't done in like a week or anything. These are months and months of work to get it right. So yeah, so and if you watched my last video, I looked at the Z80 simulator, and the plan is to do something like this in the future. So bye bye.